In this video, we will discuss about heat exchangers and its types with respect to the hot flow and cold flow. So, first we have to about what is a heat exchanger. It is a type of equipment. It is based upon the concept of thermal reservoirs and power plant concepts. So, in this heat exchanger is normally classified into parallel flow and another one is in a counter flow. This is the two types of heat exchangers. So, in this parallel flow and counter flow, we have to find about heat transfer rate of this equipment. So basically, heat transfer of heat exchanger is defined is from UA del T M. So here is the Q is the heat transfer and U is the overall heat transfer coefficient and A is the area of the particular equipment and del Tm means it is in a logarithmic mean temperature difference. Del Tm is equal to logarithmic mean temperature difference. So in this del Tm is basically categorized or basically depends on derived to parallel flow and counter flow. For parallel flow it is a one type of del Tm equation and is same like that for counter flow it is in a one type of del Tm equation. So in this parallel flow and counter flow we have to or we need to find out the logarithmic mean temperature values and substitute this logarithmic mean temperature difference value in this heat transfer equation. We get it the overall heat transfer rate of these heat exchangers. So this is for parallel flow and counter flow concept. For additionally, we have to focus upon in this parallel flow or counter flow with respect to the single tube exchanger or multi tube exchanger. So in this single tube exchanger or in this multi-tube exchanger, we consider this type of criteria. At that time, the heat transfer equation will be transferred to considering correction factor adding this equation. Q is equal to F UA del T of M. So here F is the value of correction factor. To find the correction factor for this heat exchanger analysis, we focus upon or we consider upon the X and Y value of this heat exchanger graph. In this X value, it will be located at the axis is the P axis and this curve value it will be located as R is the one of the value. So we find out the P and R to find the correction factor is, if we focus upon the X value is P, it is the, we consider about P is the value of 0.45 and R is the curve value is focus upon 0.76. We mapping R, we need to draw about the P and R value in this graph. P is the value is 0.45. Consider this is a 0.45 and counter curve value is 0.76. This is the curve for 0.76 is R. So we are correlating this X value into the curve values. It will be located as this is a P and this is a R. If we have this value, it is the correspond correction factor value F. So this is the value of the correction factor F for the given heat exchanger or multi exchanger heat phenomena of in this single flow and counter flow. For this, we consider a multiple section, the flow parameters will be divided into mixed or unmixed flow. So if unmixed flow, we have to focus upon correction factor, and unmixed for normal flow, we have to only focus upon this type of Q level. Thank you.